right, we're going to be reviewing for the quiz that's coming up with this video. We're going to be talking about graphing parabolas, changing standard form into graphing form, graphing inequalities, and graphing absolute value equations, and solving inequalities, both absolute value and quadratic. They're very similar, and they kind of go together. So we're going to start with graphing. I was going to start with problem number 3. The direction stated graph and identify the vertex, then graph. We will go ahead and do that. We will start with identifying our vertex. We know our vertex involves the numbers 4 and 3. X is 4 and Y is 3. Now the question is, what are the signs of those numbers? So if I recall, X minus 4 shifts 4 units right. So X minus 4 is a shift of 4 units to the right, which means it's a positive 4. Minus 3, change color here. This minus 3 is a shift of 3 units down. And so it shifted 3 units down, which makes this a negative 3. And so there's my vertex. So the very first thing I do is plot that vertex. I've got 4 and negative 3. My vertex goes right here. The next thing I need to do is consider what might have happened. So A is equal to 2. And since A is 2, it means it's been stretched a factor of 4. Of 2, excuse me. So I'm going to start at this dot, and normally my normal dots, which I will do very lightly in this lovely yellow color, my normal dots would go 1 and 1, 2 and 4, 1 and 1, 2 and 4, like that. That's my normal dots. But with a stretch factor, I need to take this dot, and instead of going up 1, I'm going to go up 2. And instead of going up a total of 4, I will go up a total of 8. So it's right there. And then this one's here. This one is also doubled, making my parabola very skinny, like so. So what you can see here is, first is identifying the vertex. And if you recall our shifts from our parabola lab, which was our Desmos activity, how we know, oh, if I want to move it to the right, it has to be minus. And so that's 4 units to the right, which makes it a positive 4. This 3 is an up and down movement. Since it's shifting down 3, it's a negative 3 for the vertex. Stretch factor is the hardest. Take your basic dots, double them. If it's being stretched by 2, if it's being stretched by 3, you triple them. If it's being compressed by a factor of, say, half or 2, then it would be divided by 2 or multiplied by 1/2, whichever floats your boat. Okay, so that's question number 3. So let's pick one of these. We're going to do number 8. So let me move my camera up. So we're going to do number 8. And we need to put it into graphing form, which means we want it to look like A parentheses x minus h squared plus k. So that's the form we want, and this is what we have. The very first step to completing the square is to remove the leading coefficient. So we're going to go ahead and subtract this 3. Divide the 3, so I'm going to put plus 6x here, and then close that out. So take a minute and think about that, and we'll be right back. Okay, so then I need to figure out what squiggle is. So we can either think in our minds or draw. X squared, we have to split 6 in half. So 6 gets split in half, 3x and 3x. Meaning that my sides are x plus 3 and x plus 3. Making this number right here 9. So this is the part that gets weird. Squiggle is definitely 9. These parentheses right here become x plus 3 squared. Okay, the minus 3 sits there, but it's doing something else. This means I have 3 squares. So I just have 3 squares sitting over here. Not 1, 3, which means I have 9 3 times. This 9 is there 3 times. And since it's a negative 3, this 9 right here is really negative 27. 3 times 9, negative 3 times 9. So that's what I've really added is negative 27. So I need to add 27 to undo that. 3 squares, 9 3 times, but they're negative 3. And so I'm going to add this 27 because this 9 is really being removed because of the minus sign 3 times. So I add 27 and this becomes plus 8. So my vertex is at, and I should say y equals. Okay, my vertex is at 3 and 8. The 3 is shifting to the left. That makes it negative. The 8 is shifting up. That's positive. So there's my vertex. My direction of opening, it opens up down because of the minus 3. Be careful about negatives, especially with the whole adding, subtracting thing. If that's a minus sign, even though I read plus 9 here, I really have to, I'm subtracting multiple times. Okay. 5 is also tricky like that. We have that minus. And then on 7, we have a 2. So 8 is the hardest of all of these. That's why I chose it. But you should be okay with the others. See how you do. Alright, so now we're going to be looking at graphing absolute value equations. It doesn't matter to me. These are all equal. I'm going to go ahead and do number 10. The first thing I do need to do is identify the vertex, even though it doesn't ask. So my vertex, I've got a shift. Excuse me. So anyway, we're identifying the vertex. This has been shifted. Now the numbers 2 and 3 are involved in my vertex. Excuse me. It's been shifted left 2, making this 2 negative. It's been shifted down, up. Up 3 because that's positive. And so it's going to be negative 2, positive 3. So negative 2, positive 3. Once I found my vertex, I need to consider what's happening with this number. Now, when it is an absolute value equation, it is really 2 lines. And that's the slope. So one has a slope of 2, and the other has a slope of negative 2. So whatever this number is, positive, negative, that's always true. They switch. Whatever number it is the slope on the right of the graph. So as I move to the right of 2, I have a slope, to the right of the vertex, I have a slope of negative 2. That's down 1 over 1. As I move to the left of the vertex, I have a slope of positive 2, which is down and left. And there's my pretty graph. Absolute values are much, much, much easier than lines. And that's where we'll leave it for now. So I was just finishing up this problem. And again, these are much, much easier than, since they're just lines, you just use slope. All right, let's move on to the harder part of this review, which is down here at the bottom. The solving inequalities is the much harder part. This is what we learned in lesson 9.2.1. So just depending on which group you're in, I think we all did it on the same day, but 9.2.1 is where this is from, and it's really tricky. It really, really is. The first thing you do is pretend, okay? And with the 15 and 16, it's straightforward pretend. We're gonna let's start we'll start with 16. First thing I do is pretend it's an equal sign. So I'm pretending it's an equal sign. Wow, that's really, really, really blurry. There we go. Pretending it's an equal sign. And so I just solve it like it's an equal sign. I'm going to go ahead and add 6x to both sides and subtract 1, which gives me this equation. Then I'm going to think about trying to factor it. Always try and factor first. X squared 8, multiply to make 8, and 6, multiply to make 8, add to make 6. What are those two numbers? Yep, 2 and 4, so 2x and 4x, x plus 4, x plus 2. X plus 2 equals 0, x plus 4 equals 0, which means that x is equal to -2 and -4, and those are my boundary points. So I just solve it in a normal fashion so I can find my boundary points. That's with a quadratic. Then I have to think boundaries. So that's where my number line comes in. I'm going to use a different color for the number line. It's pretty blue. So boundaries. We've got -2, -4, excuse me, and -2. We've got our 3 sections we've cut our number line into. So we have the numbers between -2 and -4, and the numbers bigger than -2, and the numbers smaller than -4. So those 3 sections. We need to test each section and see which one is the right one. So we're testing each section and seeing which one's right and which one's wrong. So I'm going to go ahead and test 0 over here. My test value is 0 right here, -3 right here, and -5 over here. I'm going to test back here in the inequality and see which ones are true and which ones are false. Now what I do know right now is that these are filled in circles because it says or equal to in the inequality. So I'm going to go ahead and fill in my circles, and I'm going to test. So I'm going to start with 0 because it's easiest. 0 plus 9 is 0. And then 1 minus 6. And so that's false over here with 0 because 9 is not smaller than 1. So mostly I test in my head, but I'm writing my test down for you today. So now we're going to test -5. So that will give me 25 plus 9, smaller than 1 plus 30. That's 31, it's kind of close. This is 34, and no, it's not smaller. So 5 is also false. So we hope for certain that -3, we really hope -3 is true. So let's go ahead and check. We'll have 9 plus 9 is less than or equal to 1 minus 8, plus 18. So that's 18 is less than or equal to 19, which is true. So this one is true, which means my answers are in between. And so then I have to write my math for in between. X is in between or equal to -4 and -2. That's my answer. Okay. Let's try. I used all my space for 14, but I really want to do 14, so I'm going to do it anyway. So bear with me. I'm going to go ahead and do 14. I'm going to give myself some space. So we're going to go ahead and do 14. Okay, I'm just going to make myself room. It's all good. So this is different. So what I know right now is that my screen is really blurry. I know. Okay. What else I know is that there are tricks for this. Okay. So what we're going to do is the stuff inside is 53. because the stuff inside is either positive 53 or the stuff inside is negative 53. Those are the two things I know. I'm so sorry about the blurriness today. Okay, so let's go ahead and we just solve these. So we set them up and then we solve them. We'll subtract 7 from both sides. 10x equals 53 take away 7 is 46. Yeah, 46. Divide by 10 and x is 4.6. Solve the other one. Subtract 7 from both sides. 10x equals negative 60 and x equals negative 6. Divided by 10. And so those are my boundaries, just like before. Just like when I was doing this and I found my boundaries, I have just found my boundaries. Okay, so my boundaries on my number line are negative 6 and 4.6. And again, I've created 3 areas. And I will test 3 different points. So from this area, I'm going to test like negative 10. From over here, I'll just test positive 5. And in the middle, I always choose 0 whenever I can. So in the middle, I'll test 0. So let's start with 0, because 0 is awesome, and we're testing back here. Always testing in original. So when I plug in 0, I get 10 times 0 plus 7, which is equal to 7, absolute value. So 7 greater than 53? No. So 0 is false. That looks like of. So I'm going to go ahead and write false above it so that there's no confusion. So it doesn't look like the word of. So that one was false. Now I'm going to test 5. So then I'll have 50 plus 7, which is 57. The absolute value of 57 is 57. And that's true. Okay. Negative 10. Negative 10 times negative 10 is negative 100. Plus 7 is negative 93. The absolute value of 93 is negative 93 is 93, and negative 93 is larger than 53. So this one is also true. So we have these two are true, and that one is false. So when I write down my solution set, and this is the part that's a little confusing for nearly everyone I've ever taught this to, and maybe it's me then, right? It's probably me. But x is less than or equal to negative 6. That's this part. Or x is greater than or equal to 4.6. It cannot be both at the same time, so I write the word or in between, and that is my answer. I cannot put these together. If I put them together, I'm saying x is between, and x is not between these. X is not between these two numbers. It's outside of these numbers. If I use what's known as interval notation, I'd have negative infinity instead of negative 6. Negative 6 is included. And then I would have over here 4.6 to positive infinity. 4.6 is included. And then we write the word or in between. Different with this one is if I put this one in interval notation, it would be negative 4, negative 2. It would just look like an ordered pair because it's included. Whereas this one, we're leaving out the middle. Does that make sense? I hope so. Good luck. I'll talk to you guys soon.